Good evening, everyone. Today's session is on computer vision. So, as we know that in our previous sessions we have covered the domains of AI, that is data science, computer vision, and NLP. So, today I'm going to start with some applications of computer vision. What is the process of computer vision? How images are read by the computer? How computer is able to see the images? So, let us start with this session. First of all, I have already discussed in my previous session. So in continuation with that, the what is CV? CV is a computer vision and it is one of the domain of AI that depicts the capability of a machine to get and analyze the visual information. Right. So we will be identifying the different objects from an image, and then accordingly the model is going to provide the solutions or predicting anything. Right. So here the entire process involves image, acquiring of data, screening of data, analyzing of data, identifying objects from the image, extracting some information from the images, right? So our input to this particular system, to this particular model, can be photographs, can be videos, can be pictures, right? And you can take these pictures from any of the source, right? Like we have discussed the various sources from where we have collected the data, right? So they are segregated into two sources. The first is offline source and the second is online sources. So if I'm talking about online sources, there are a number of websites which are providing the data sources. So you just directly move into that, click on that particular link, and you can download the images or downloading the data set. Whereas when we have some offline sources, we can have our sensors, we can have our indicators, we can have our cameras footages, we can have our APIs, we can have our observations. So there are a number of sources where we can collect the data set, and we can train our model with the help of that particular data set. Now, let us see some of the examples of computer vision. As we all must be aware of self-driving cars, or you may say automatic cars. This is one of the application of CV only. CV systems can scan live objects. Basically, a car is moving on the road and it is identifying the different objects that is surrounded by that particular car. So, it is not only a feeded type of thing. That data is already trained with that particular machine, but the car is moving like around any road. It is taking the real time pictures, and then the system is going to scan those pictures, and then based on that it is going to provide you the predictions, like where you need to stop, where is red light, where you need to walk, or where you need to drive, what is the speed limit that is to be maintained, which route you are going to follow, or what are the different things. Like when you are driving, it is same, but here we have self-driving cars. Here there is no driver. Like in case of autopilot, also nowadays we have autopilot. The autopilot is going to have a, like it is in the airplane or it is in the aeroplane, and that particular pilot is going to manage all the things. It is going to predict which object is coming in front of that, and it is also moving in the sky. It is like it is scanning the live objects that are surrounded by that particular plane. So this is how it is implemented. It is one of the example of computer vision only. Computer vision related projects translate digital visual information. I have already discussed this thing. The input to this particular model is visual images, some visual information. This could be your videos, this could be your images, or this could be your any picture kind of thing, right? So any visual information can be given to this machine for training that particular model. This data is then turned into computer readable language to aid the decision making process. So basically, behind every picture we have some pixel information, right? Now how the computer is going to identify these are the different objects that we have on our system. So there are edge detection algorithms that we have in computer vision that is going to define the different edges of a particular object and then segregates that object from that particular picture. So this is how the images are segregated. We will be in the later slides, we will be checking out like how the segmentation of an image is going to take place, or how multiple objects are identified from a particular image. The main objective of of this domain is to teach machines to collect information from pixels. So basically behind the scene we have the pixel information only. We don't have blue color, we don't have such kind of thing. We have the coded pixels, like we have the pixels information which is already having the color information and edges information, right? So in my coming sessions I'm going to give you one example how a picture is going to convert it into a numbers, and what are the things like how computer read those images, how computer is able to see those objects from an image, right? How it basically segregates the edges between two objects. So this is basically edge detection algorithm behind that. Let us take one more example of this. You have face lock in your smartphones. Nowadays, everybody is using face lock in their smartphones, right? So you have basically you feed your pattern into the computer in front of your phone, and it is going to unlock your phone. The front camera detects and captures the face and saves its features during initiation. So before going through that, before implementation, sometimes the computer is going to give you it does not recognize your face. So whatever patterns you have given the model as an input, it is going to recognize only those patterns. Beyond that, it is not going to work. So basically when you are training your model with some images, you need to train the model with all the patterns. Like if I'm taking my images like this, I'm taking my front face, I'm taking my left, right, and all the like retina, everything I'm going to take is as a pattern that is going to be feeded into my machine, right? Next time onwards, whenever the features match, the phone is unlocked. So this is how a picture is identified by the machine, how a computer is able to see our faces and going to react on that, like whether to unlock or whether to lock our phone, right? Let us see some of the applications of this computer vision. Basically the concept of computer vision was introduced the first time it was introduced in the 1970s. All these new applications of computer vision excited everyone. Having like a computer vision technology is like you have Snapchat filters you are using, you are putting some emojis on your face, and it automatically identifies like this is your eyes, this is your nose, this is your lips. How it is going to identify? It has some recognition kind of thing, right? So it is basically very much intelligent to recognize your features from your particular face, right? So how it is going to do that? Basically it has that information, the pixel information it has, right? And then automatically it takes that pixel information and going to convert the pattern into a pixel information, like your eyes pattern, or maybe someone has feeded only retina pattern as a input to the machine. So it could be anything, it could be your face. And sometimes like we are putting a mask on our systems, and then um, say like facing or anything like facing on a camera, or using any smartphone, or like I am using a attendance system where I need to unlock my I need to stand in front of that particular machine, and that particular machine is going to take the pattern of my face. Now sometimes I put mask and it is just give the output stranger. So why it is giving me the output that is stranger? That is why because the patterns that are given as an input to the system are only without mask. If I have first time I have given that input as a with mask also, it can identify because the retina pattern of everyone, would be different for different faces. So most widely used patterns that we use to unlock our phone, or like for high security system, we have such kind of machines which is only going to take your retina pattern, like your Aadhaar card also. Why they are putting they are taking the while taking your pictures, they are putting something on your eyes only to take your retina pattern. Why? Because it is very very authentic. Yeah, everyone, like your biometric also, your fingerprint also, it is taking as an input. Why? Because it would be different for different people. It could not be same for everything, could not be saved. And how it is converted, how computer understands, like this is my retina and this is someone else's retina, based on the pixel information. Right. So these are some applications of computer vision only, and we should know like how we are using such applications in our real life. Right. Next is face filters. Everyone is like nowadays downloading some app. You may have Instagram, you may have Snapchat apps, which basically their features are based on computer vision. The applications of face filters is among them only. Right. It like I am putting some emojis on my face. Yeah, I am putting some facial filters on my face. So they all are coming into this field only, this domain only, that is computer vision. Like through the camera, the machine or the algorithm is able to identify your facial dynamics of the person. It could identify the different features on your face, like this is my nose, so where to put the emojis. It basically, when it segregates the different object, the different features on your face, and automatically it is putting the different filters on your face. So how is it possible? With the help of the application, or with the help of the domain of AI, that is computer vision. The next domain is we have is computer images. Like we are searching on Google search by image. Nowadays, you can click that particular image and search that image also. How is it possible? With the help of CV only, the as it compares the different features of your image with the images that are already fed into the database, and then it is going to analyze that particular images and gives you the most accurate result. So this is how this is one of the application of computer vision only. So earlier we have text part, like whatever is written on the screen, and if you type that particular word on your Google Assistant, or you are searching on Google, it is going to find out everything. Nowadays it is possible to have search for Google for search for images also. You can search by basically not only by text, you can search by images also. You just take a picture of that, you just click that particular picture, and automatically it going to provide you the results based on the input. So this is also one of the application of CV. Then we have self-driving cars that I have just now discussed, how basically it identifies the different objects, getting navigational routes, and also at the same time environment monitoring, like what is the temperature, and like it has some ultrasonic sensors also, like it is going to provide you the distance, how to maintain the distance between two objects. So there are a number of things. This is not only like the application of CV. You may have to involve other technologies too for this, like Internet of Things. You need to have some sensors part in which you need to communicate between two objects. Right. Another thing is when you have computer vision in medical images also. Now, medical imaging, computer supported medical imaging application has been trustworthy help for physicians. Nowadays, everybody is using that particular device. Now, what this device does is it becomes an you may say an assistant, and it helps the doctor with their interpretations. Right. The application is used to read and convert the 2D scan images into interactive 3D models. So now it is not only a doctor is, and based on that particular image it is going to predict also. So there is not only imaging part, there is prediction part also, which is basically suggesting based on the past history of the patient, the past history of the patient related to their medicine also, like this patient is used to have some allergic, you may say, reactions with this particular medicine, right? So the machine is going to prescribe those medicines which are not going to affect the patient also. So these are what are these are some applications of CV. The most important part we have in this is how the computer is segregating the images, how it basically performing the different tasks, how it identifies the different objects. The various applications of CV are based on certain number of tasks which are performed to get certain information from the input image, which can be directly used for predictions or form the base for further analysis. The task of this is like we have single object, right? If we have a picture and we need to analyze only the single object, so we could be using classification techniques, like our images are divided into like different objects, we can classify it because we have only single object in our picture. Now if we want to identify with the location also, like it segregate, it classify also, and with the location part, like your picture definition is in particular location in this particular area, right? So it is classification plus localization. Now this is for only single image, when we have object segmentation for single image. And next thing is when we have for multiple objects, when we have in a picture, I'm going to show the pictures also. When we have multiple objects in a single picture, right? So how to detect the different objects from the like image? So it is one of the tasks of CV only, how to instance the segmentation, how to basically find out the, or you may say segregate the instance or an object from the image. So let us see some of the more important points into this. Image classification problem is the task of assigning an input image one label from a fixed set of categories. This is one of the core problems in that in CV, that despite its simplicity, a variety of practical applications are there, right? So, and I have already told you this thing about identifying what the object, which object is present in that particular image. At the same time we are collecting the location also, right? In a particular image, the trees are coming in this particular location, right? Or the cars are standing in parked in this particular location. So you are segregating a particular image only. If we have different objects, we have different real world objects, and such as faces, bicycles, or you may have buildings in images or videos, we can segregate those also, right? We can detect those also. Or you may have instance segmentation. In instance segmentation, you basically you are collecting the pixel information, right? And then it make a segment. This is how these task has to be implemented. Let us start with the first image, that is classification. You are just having a single object and you are just finding the you are not even finding, you are just identifying. There are behind this you may be seeing some trees, some grass type of thing, but we have only single object in that. So we are only using the classification technique for segregating this type of picture. The second is, now you are just focusing on that particular area, on that we are basically localization is performed in this particular task, where we are finding the location where this object is like coming. You may find out the pixel. How you are going to find out this thing? Through pixel information only. You may be finding some edges of the ears of that particular cat and some eyes patterns, like how it is segregating the different colors also. Like later on we will be seeing how it segregates the different edges or different pixel information. How there are two algorithms in this. We have the pixel algorithm also, we have edge detection algorithm also. So edge detection talks about only find out the edges, like in the object detection. Now you have multiple objects, now you are identifying the different objects in a single image, right? Now the image is single, like you are taking one picture only, but there are multiple objects. Now you need to segregate those multiple objects. So you are going to have a task, that is object detection, right? So this is very very important. When we are using CV, we should know like there are various tasks. The first is classification, the second is classification plus localization. When we have some location kind of thing, we want to find out the location of that particular object, right? Then the last is, it is again for multiple objects. We are taking the whole picture of that particular image, right? We are just finding the edges. We are finding the objects in object detection. But if we want to find out the real edge of that particular object, we will be using the instant segmentation, right? The complete picture. Otherwise, you may see before that you have object detection. In object detection, you may be completing a complete object you are taking, right? You are taking the picture of complete object, just segregating the detecting objects, like these are some objects in an image. Whereas when we have instance, you are taking the edges of that particular object also. So like this, in this, we in the first picture, we may see there is a single cat, single object. The second is where this cat is lying, right? Then we have multiple objects algorithms, that is object detection. We just segregate from like how many numbers of objects are there in that particular image. Then in instant segmentation, we may be finding the edges part of that particular object, right? And this is basically focusing when we have two things. When we have single object, there are two algorithms, classification and classification with localization, right? In multiple objects, we have object detection and instant segmentation, right? Now let us see how we basically implement those pictures, right? How we are taking these pictures and we are implementing in our Python, right? You need to, like I have discussed in my session, when we are downloading the Anaconda prompt, right? And then we have open the open the Jupyter notebook. Before that, we need to, like, if we are going to use the computer vision concept or the algorithms or the functions that are defined in Python, we need to install this library, that is OpenCV. You give a hyphen or dash and then Python. So pip install, this is the function. This is basically the command for installing the OpenCV. Pip install, and this is only for like if we are installing it on Anaconda prompt. You may install it with conda install OpenCV too. So there are different installations also. There are different commands also, but you may have the same library. You may have to access the same library. Now, what is the need of this library? Why we are using this library? Right. So we are using this library. What is the importance of this library? Let us move into this part also. Like in this chapter, in this particular chapter, like OpenCV, I will be making one more session on this. How in this particular session I'm going to give one image as an input, and I'm going to change the colors of that particular picture. I like whatever functions you are performing on your phone, like cutting something or resizing your image, zoom in into the particular picture, saving your pictures, then first to edit the picture and saving the pictures, or adding some text into the pictures, right? So how we are basically performing the image processing task, they are done with the help of this library, that is OpenCV. So OpenCV is this is also a open source library. You need not have to have some license or like this kind of thing, right? Or you need not have to purchase from this certain some website or this. They are free to use, open source library, and this helps the computer extracts these images, these features from the images. So what are the features? Like if you want to extract some if you want to perform some instance segmentation, you may be using that particular formula, or you may be using the different algorithms. So these all things, the things which are coming on my screen, all the tasks which here, like which are appearing for a single task or which are appearing for multiple tasks, you can implement with the help of OpenCV library. So this is the library which we will be using in our sessions, and to manipulate the or to perform the different functions, or you may say the image processing operations on a images, right? It could be resize, it could be zoom in, it could be cropping, whatever functions you are performing on your phone on an image, you can perform it on the system also. You can perform it on the using this library also. It is used for all kinds of images. It is not meant for only like I am using only for JPEG. No, it is meant for all kinds of images and video processing and analysis. This is not only like basically we have only the standard format, like we will be using PNG or we will be using JPEG, right? But the thing is, most of the time we like I have used most of the time PNG images or JPEG images. So basically we can have any kind of image, right? It is capable of processing images and videos to identify objects, faces, or even handwriting. It is not only meant for like your to recognize only these kinds of images or faces only. You can recognize the handwriting also, right? So there are number now by like I'm going to end this session. Before ending this session, you need to understand like why we are using computer vision, right? What is the concept behind that? So the concept is like whenever we are dealing with images, whenever we have visual information that needs to be you may say identified, some we need to recognize some objects, and how a computer is able to see those objects, right, from an image. So this is through only computer vision, right? And how we are going to implement it? We are going to implement it with the help of that is CV tool only, or you may say it's a CV library, that is open CV. Sometimes like when I was installing on my system, and it is going to take the command open CV2. Sometimes like how to import that file in your programming, you may import it like this only, like open Jupyter notebook. First you click on anaconda prompt, then open the Jupyter notebook, and then just start to import this particular file, and you can start with your like just take an input as any image. You can take it and you can perform any function. You can perform any image processing functions, and then you can even while making the changes, like you are adding some text or you are resizing your image or you are putting some text, right? Anything you can do it, right? And after that you can save that particular image also, right? Like I have taken as input one image and I am going to modify that particular image. I want to perform number of functions on that particular image, and then later on what I'm going to do is I'm going to save that image for my reference, right, for using that picture. So it's like a handy camera only when you are doing programming with Python. And you need to have only these packages like OpenCV, Matplotlib, or Pandas. But see, for CV, for computer vision, we have only this. We need to use this package, that is OpenCV, right? So thank you. Hope you like the session, and we will be coming with more sessions, which is basically focusing on how to have a input, how to have a image as an input, and then applying these operations. Then basic operations on an image can be performed, you can resize that particular image and then save that particular image, right? So thank you.